The last example here of ellipses we want to look at is an application problem. And the setup is that we've got this doorway. This doorway is 5 feet tall on the side and 6 feet wide. And from the center of the doorway, it's 7 feet high. So the setup here is we've got a side of 5 feet, we've got a semi-elliptical top, and if I were to stand right in the middle, it is 7 feet tall, and then it's 6 feet wide. So this is not drawn perfectly to scale, but you can see the idea of what this doorway is going to look like. We know that if the sides here are 5 feet and the absolute top of the doorway at the center of the ellipse is going to be 7 feet, that means this half of the ellipse here has to be 2 feet. Because if the total is 7 feet, I've already got 5 feet, that means I've got 2 feet. My goal then is to figure out where would the foci for this template of the ellipse be placed so that we can make this arch. So the foci we know lay on the major axis, and they're the set distance away from the center. In fact, it's the C value from the center of the ellipse outward on the major axis. So in order to do that, I need to find my C values. So we know for foci, C squared equals A squared minus B squared. But just looking at that picture, I don't have all the information yet. So let me start by drawing out my ellipse. I know that the entire length here has to be 6 feet because that's the width of the door here. So the width here is going to be 6 feet. I know the height here is 2 feet, and that means the height downward for the ellipse also has to be 2 feet. So my major axis length is 6, and my minor axis length is 4. So once I get that, I can figure out what my A values are and what my B value is. So here, A is going to be 3 and B is going to be 2. The reason for that is the major axis length is 2A and the minor axis length is 2 times B. So if we divide both sides by 2 for the lengths, we get our A and B values. So now if I go C squared equals A squared minus B squared, C squared equals 9 minus 4, C squared is equal to 5. So C equals plus or minus the square root of 5. That tells me where my foci should be listed. They should be plus or minus square root of 5 feet from the center. So if my center is right here, I would go out this way, square root of 5 feet, and go this way, negative square root of 5 feet, to figure out where that foci would be. The next concept we want to look at is how does a circle relate to an ellipse? And you worked with the circle and ellipse relationships last year in college algebra or algebra 2, so I'm going to go through this pretty quickly. You know that A is equal to B. You know that C is equal to 0, where C times E is the distance from the center to the focus. The foci are at the same point, so there's really only one focus. The minor axis is the same length as the major axis, and the eccentricity is defined to be 0. So if here we've got C times E, and we know the eccentricity is 0, C times 0 is 0, which is why C is equal to 0. And A equals B means the lengths of A and B are equal, which ties directly to that the minor axis is going to be the same length as the major axis. The other thing that's not specifically listed there is the equation for a circle. And the general form for the equation of a circle is x minus h quantity squared plus y minus k quantity squared is equal to r squared. So for example number 6, what is the center and radius of the following circle? Well, we've got our formula here for our standard form of a circle. Our coordinates for the center come from the pieces that are inside the quantities. So there I'm going to have -7 and +16 as my center. My radius is the square root of the number on the outside, which is going to be 7 in this case. In my second example, the center, 3, -2, the opposite of those two numbers that are inside the quantity squareds, and the radius is the square root of 67. Now, if you have something that is not in standard form and I want to know what is the center and radius going to be, I need to complete the square. And that's what we see in example number 7. Find the center and radius of the following circle, and how would you enter it into your graphing calculator while we're in rectangular format. So for this, I first need to complete the square. So when we complete the square, we group our x's and our y's together, and I move my constant to the other side. Then I take my x quantities, and there's going to be some number I'm going to add to the back. I'm going to take my y quantities, there'll be some number I add to the back, and whatever I add to the back of each of those quantities, I have to add to the back of the other side of the equal sign. So the pattern that we do is we take half of my b term and then square it. So right here, half of -10 is -5. -5 squared is +25. So both sides I'm going to add 25. Half of -6 is -3. -3 squared is 9. So we'll add 9 to both sides. So in this group here, x squared minus 10x plus 25, that can be factored down to x minus 5 quantity squared. Here, y squared minus 6y plus 9, that can be factored down to y minus 3 quantity squared. And that's equal to 9. So now that I've got my equation in standard form, I can determine that the center is going to be at 5, 3, and my radius is going to be 3. The other piece then is how would I enter it into my graphing calculator? And I can't use this original problem to enter it into my graphing calculator in functional mode because I've got two y's in the same side of the equation, or in the same equation, period. I've got to use my standard form here and then solve for y. So if I have x minus 5 quantity squared plus y minus 3 quantity squared is equal to 9, we want to get this y by itself. So we'll move this whole quantity to the right-hand side. So y minus 3 quantity squared is equal to 9 minus x minus 5 squared. Take the square root to both sides. And when you do that, you get a plus or minus. And then finally, we'll add 3. So 3 plus or minus the square root of 9 minus x minus 5 quantity squared is what I would plug into my calculator. The y1 would be the positive version, the y2 would be the negative version.